And I'm gonna share the screen. First thing I wanna do is, the exam was scheduled for next week, but we didn't cover everything that I want to cover for the exam. So let's postpone it another week. Rules above. And goes up. More students coming in. I want to make sure it's fine with you all, folks. Oh, wait a minute. I put in the wrong date. Sorry. Let's see. This guy is supposed to go here, right? And what about that? Let's see. Shift cells down. This entire column. Shift cells up. Yeah, let's see. No, didn't work. Must be this one here. Delete cell. Shift cells up. Now that should work. Yeah, it works the way I want. Put it on red. And this one's gonna be on black. Okay. It's gonna be on Monday. That's today's meeting. And it shouldn't be a sig figs and measurement, should be sig figs and results, because we already covered the sig figs for measurements. Okay, am I sharing the right screen? Let's see here. Just confirm with me. I'm scrolling up and down the screen. Just confirm that you see the right screen, please. And I'm gonna delete that as well. I have 3 screens here, and sometimes I get lost, navigating on those 3 screens. I still didn't get used to 3 screens. I was used to 2 screens only. And thank you, Vanessa. Thank you, Ashley. Okay, so is that clear what we are doing here? We are changing the date of the first exam. It was initially scheduled for next Wednesday. I'm scheduling it now for the other week, for the other Wednesday. We need a little bit of time to finish chapter 2, right? I'm not sure we'll be able to finish lab 1. I'll keep you posted on that. Okay, yeah, since we're going to do let's see, today we finish lab 1, maybe there will be some other things. Okay, so let's see how it goes. So my question is, everybody can make it on October 4th for the first exam? That's my question. Okay. If you don't say anything, I'm going to assume, right? I'm going to assume that is okay to change. Okay, change it, exams, first exam date to October 4, 2023. Exam. October 4, 2023. And the situation is the following. Let's quickly review what we did last time? Last time was the 13th of September. Okay, and that's the material, right? Let me see if I'm gonna copy and paste the summary here, there below. And I will add some other things for the lab one. Huh? Okay. So far, for lab one, we did the following. I showed how to put together a table of data in Excel. So what we did so far. Yeah, let's just put how to plot your data in a graph using Excel, how to label the axis of your graph, and how to adjust the units along the axis, not the units, but the divisions, right? That would be a more appropriate along the x-axis. How to display the trend line regression equation in your graph, how to display the R-square value of your graph, assign the lab groups, how to find the confidence level of a regression equation with respect to its data set. What else? I talked about significant figures, right? I distributed the spreadsheet. Let's see. Let's switch here. Talking about significant figures of the measurement. I distribute the spreadsheets of the first lab. Okay, I introduce you to the ruler. Well, the ruler you already know, right? Vernier caliper and micrometer. Discussed the resolution of the above instruments. I also told you about that, and also told you about the scale, right? I told you about the scale we use in the lab. Discuss the resolution of all the 4 instruments, of all 4 instruments. We use in the lab. And what else? Yeah, here you go. Significant figures of a measurement. That should go elsewhere. About the scale, discuss the resolution of all instruments. We talk about significant figures of a measurement and how they relate to the resolution of the instrument. Right? Instrument. We covered lots of things. Let's go back a little bit more. Let's see if I'm forgetting anything else, just to refresh your memory what we did. And I'm recording here. Let's see. You go. Yeah. Resolutions. Scale. What else did we do? Yeah, that's how we did, right? There's nothing else. The only other thing that we did, we look at the density of the steel. We look at the density of the steel, nothing more fast than that, right? Equal micrometer. This is a picture of my micrometer, remember? And this is the Vernier scale of my micrometer. We don't use those micrometers in an actual experiment, but this is just an example of how you can adapt the Vernier scale from a linear device to a rotational device, right? Angular device, like from a linear scale to a rotational scale. Okay, so that's what we did. Well, I also showed the simulations, right? Showed the simulations of the vernier caliper, the micrometer. That's what I did. Lot. You see how much stuff we cover? You know, that's why it's sometimes it's difficult to learn everything because so much material. So much material. Assign you to labs, to lab groups, to lab groups. Huh? I distribute the spreadsheet of the first lab, right? So go ahead and what I'm going to do now, today. Today, I hope to finish lab one. Today, I hope to finish lab one. I think we're going to be able to do that. Okay. Today. One. I believe I did that before too, right? Today I'm going to show you, today, I'm going to show you, I think we did that last time, show you how to adjust the sig figs, right? Sig figs of the measurements, the spreadsheet. Remember, I think I did that last time, but I'm going to do that again, just to have fresher memory. How to report the sig figs of a measurement, not a measurement, but a result. Remember? Measurements versus results. And versus results, right? Or raw data versus data that has been operated on, okay? Like that. Measurement should be the raw data. Let's put that between parentheses. Oops. And I will remove this other parenthesis here. Results. And what are results? Results are data that has been operated on. How to report the right number, right number of sig figs of a result. We're gonna plot 3 different graphs with the data we have. Plot 3 different graphs with the data we have. And let's see. Complete. Let's see. Let's not report the proper CL and percentage differences with respect to the expected measurement, with expected result. That's what we're going to do. Today we're going to do the following. We are going to do the following. We're going to adjust the sig figs of a measurement of the measurements in the spreadsheet, right? Report the right number of sig figs of a result. You already should know how to report the right number of sig figs of a measurement. Okay, plot three different graphs with the data we have. Report the proper CL and percentage difference with respect to the expected result. And I'm going to remind you, going back here, I'm going to remind you of the resolutions of the instruments that we are using right here. Just copy it and paste. It's not that big. What did you say? Hello? Someone said anything? Did anyone say anything? Okay. Okay, so let's move on. It's like I heard, I think Catherine was talking. Okay. Okay, thank you. Thank you, Ridwan. Yeah, make sure that you turn off your mic, right, if you're not talking. And okay, here you go. Here's the resolutions, right? Resolutions, 1/10 of a millimeter, 100th of a millimeter, 1,000th of a millimeter for the ruler, vernier caliper, and micrometer. And they scale, I'm going to, sometimes it's difficult to memorize all those zeros in front, right? So let's put 0.01 grams, 100th of a gram. 100th of a gram, which by the way is equal to that. To change from grams to kilograms, all we have to do is to add 1, 2, 3 zeros here. And you end up with 4 zeros in the kilogram scale. Okay. 13 students already. So let's take attendance. No, let's do attendance later on. Let's do attendance later on. So what I want you to do now, open your spreadsheet. And let's see. You know what? Let me take attendance now, because maybe there are some students who do not have a group, right? Let's so values, group number. Okay, Nazmoon, let's see. Nazmoon, Miller. Okay, Nazmoon stopped coming, right? Is Nazmoon here? I don't think so. Nazmoon Miller, nope. Next is Donovan. Donovan is not here either, right? Donovan never showed up. And Tessa, are you there?
Yeah, I'm here.
Thank you, Tessa. Destiny?
Yes, I'm here.
Thank you. Gael? Garcia? Thank you. Ridwan is here, right? Thank you. Now Ashley. Ashley Zumo. Okay, thank you, Ashley. Annabelle Madrigal. Annabelle. I don't see Annabelle here. Okay. Norberto Lopez.
I'm here.
Thank you. Vanessa Mena.
Here.
Thank you, Vanessa. Camden.
I'm here.
Thank you, Camden. Victoria Preciado.
Here.
Thank you. Alexis Fisherson.
Here.
Thank you. Marcos Sanchez. Okay. Sky. Sky is not here today. Yeah, I don't see her. And Eric Martinez.
Here.
Thank you, Eric. And Catherine Pacheco. Okay, good. Thank you. Come then start coming in again. Okay, let's see how many students we have. 13. Yeah, 13 students. That's good. Only Sky and Annabelle are not here now. Group 2 and 5. Okay. Good. So this one, insert That's a meeting 3. Oops, not. So let's first step. Open your spreadsheet, right? And let's continue working on the spreadsheet that you have there. I already have my spreadsheet here. I am using a spreadsheet of group number 9 that doesn't exist here, right? So I don't show the spreadsheets of anyone of you here, right? So here you go. At this point in time, we should have already done the the density of steel. That's what we did last time, right? Confirm that with me, please. At this point, you must have the value of density in cell. What's the cell number? K16. Cell K16. K16. And by the way, very important, I don't think I have told you, okay? But I'm gonna tell you right now, I'm gonna put in capital letters so you don't forget it. Please do not move, do not change the positions of the cells and the cells, rows, and the columns, okay? They, in the spreadsheet, they must be at their original positions with no change. Okay. I'll keep watching for that. There's a reason why you shouldn't change. Just keep them in that position. Okay, let me show what I mean, right? What I mean about that. All those columns here, they are occupying rows K, L, and M, 27, 28, 29, 30, and 31. Do not change the position of any of the tables. And even better, do not change the position of any of the tables. That's better like that. Okay, I'm gonna write that down. Do not change the positions of any of the tables, cells, rows, and columns in the spreadsheet. They must be at their original positions with no change while you edit the spreadsheet. And like I said, there is a reason for that. And the reason to keep the original positions of them, that's because I have a computer program that's going to correct your spreadsheet. And if the cells move elsewhere, the computer program will not be able to correct their spreadsheet, okay? I'm gonna write it down here. I have a computer program that corrects your spreadsheet, and this program is dependent of having the tables at their original positions to work properly like that. Okay, so first step, let's see, looks like someone arrives, right? Is that Sky? Yeah, Sky is here, right? Just say you're here, Sky.
I'm here.
Okay, thank you. Now we have 14 students. Let me give attendance to Sky. Annabelle hasn't arrived. Nope. 14 students right now. Okay, so first step, open your spreadsheet. No, if you haven't already gone there.
I have a quick question.
Yeah,
That's the reason why when you type something in the spreadsheet that like for example, if you type like a numbers, that's why it becomes like I don't know, like becomes like out like different values. That's
Oh no, that's not the reason. That's not the reason.
Oh, that's
right?
not the reason.
No, the reason I'm gonna cover that right now. Let's see if I can give an example here. Let's see if this one works. Yeah, see this one here? I type it 1,000, right? See? It has to do with something else. It has to do with the formatting of the, and then I type it 1,000, but it's displayed like 1e plus 03, right?
Yes.
See that? If I put 1,010, right? It still displays 1,000, right? Right? If I put 1,100, it still displays 1,000, right? 1 times 10. It has to do with the formatting. Okay? It has to do with the formatting of this cell. And I'm not sure, I don't remember if I covered that. Did I cover that before? I think I covered, right? But I'm gonna cover it again. So each of those cells are formatted in a way to make you work, okay? To make you work a little bit more. So how do you change the format? You change the format in Excel by doing the following. Here you go, right click, right? There's a feature of Excel. Format cell, okay? Right now is scientific format. E plus 03 stands for 10 to the third power, okay? I want to put in the regular numeric format. If I put it in the regular numeric format, you see the exact number that you type it in there, okay? It has everything to do with significant figures, okay?
Oh, okay.
In this notation here, in this format that you see here, you have 4 significant digits. 1, 2, 3, 4. In the other, in the other format like this one, you see only 1 significant digit. It's in the format of only 1 significant digit. I did that on purpose because I want you to exercise your knowledge of significant figures and put all those numbers here in the proper format. Okay?
Okay.
So again, you don't see the correct value because this number here is being rounded. It doesn't have enough significant figures to see the correct number that you type it. That's the reason. So it's just a matter of, like I said, just a matter of formatting. Okay, and let's repeat that, right? Here you go. This one here. At this point, you must have the value of density in cell K16. Okay, and 1, 3, let's see. You should fill up all the units on the tables. All the units. We start with the unit, that those are the easiest one. And then we worry about the significant digits, right? You can see, the units for this table is already here. Kilogram per meter cube, right? The unit for the diameter of the ruler is here just as a sample, a free sample for you. But now you have to fill up the units for all those columns. Okay? Let's work on that, everybody. Get the unit for the diameter of the vernier caliper, how it is displayed, the diameter of micrometer, the unit for the volume of the ruler, vernier caliper, and micrometer. Okay, that should be easy. Everything, don't forget, we are using in this course, we use the SI units and their combination, right? So SI units, meter, kilogram, second, and their combination, right? And what do I mean by their combination? Meter square, meter cube, right? Meter per kilogram per meter cube, which is the unit of density, etc. Then I will put, by the way, the percentage is also considered a unit. Let's put here, percentage sign. This one is also considered a unit, right? It represents, what does percentage mean? Percentage means that it represents 1 divided by 100. That's what this symbol means, okay? This symbol means 10 to minus 2. That's the significance of this symbol. That's the significance of the symbol. Okay, the next thing that I'm gonna talk is the, report the proper suffix. Right, that's the next one. So let's go one by one. I wanna make sure you're doing your work there, right? And let's see this one here. I'll give you a few minutes for you to work on the units first, and then to start working on the significant figures. Okay. I will walk away momentarily from the computer. I'll be back shortly to check with you how you're doing. Okay, so I see here Alexis is asking where do we get the information for what we're supposed to do, right? So let's go back to the spreadsheet, right? So here you go. The information that you get to do what you're supposed to do. First, the units, right? It's right in here. You're measuring the diameter of the ruler, right? You are measuring the diameter, you are measuring the diameter of the sphere with the ruler. Remember, sphere 1, 2, 3, 4, 5, and 6. That's how the experiment is performed, right? The experiment is performed by getting the sphere that I provide you, you measure the diameter of the sphere, and you report it right here. Right now, let's concentrate on the units only, which is the easiest one to do. Okay? And all those diameters are being reported in what? In meters. We are using the SI system of units. So it's going to be meter here, and meter here. Okay? I'm going to save this copy. Save as sample. I'm going to put a sample. One more student coming in. Right, that's my sample. So let's go. I should put the stew density here. Do you remember what was the density here? We checked last time we checked the internet, right? What's the density of the steel that you got? Let's do that. Let's see here. And density of steel. Here you go. Density of steel in the SI unit first. We take the average of those two values, right? I mentioned to you last time that depending on the type of steel that we use is going to be anywhere between this value. Since we do not know, the college didn't tell us what alloy of steel that we are using, so it's fine. It's okay to use the average of those two values, okay? 750, 8050. 750. I'm going to, let's see here. 750 and 850, right? 8,050. So it's going to be, I'm going to take an average of those two. And like I mentioned, and I want to report it in a different format cell number. I'm getting 7,900, right? You should have something like that too, close enough. And I don't want
Professor,
both.
I have a question.
Yeah.
Do you need to use the number or general? Because like when you use general, I think it rounds up. So I use general instead of the number.
Oh no, use numbers.
Use number?
The format that you're going to use in this course is going to be either number or scientific, okay? Don't use any other format. Either number or scientific. Don't use any other format. Let's see. We are not using currency here. General. I don't like to use general. Don't use general. Okay.
But I have a question. When you apply the number, right, to spheres and stuff, then it becomes 0. Every value becomes 0.
Which number?
The diameter and like
okay. There's a reason for that, right? There's a reason for that, right? Okay, what's the reason? Do you know what the reason is?
I don't know the reason. That's why I want to know.
Yeah, right now, yeah, you don't have, yeah, just like Ridwan said, right? You do not have enough decimals there in the number, okay? I'm gonna click it here. I'm gonna give you an example. Exactly what Ridwan said, right? Right click, but we're talking about the diameter. We're talking about the units. Let's work on the units first, and then we get to the sig figs, okay? Let's do that, Cam. And then otherwise we, I want to finish the units first, right? Okay, so here you go. What's going to be the unit for the diameter with the vernier caliper? It's going to be meters. Everything here is going to be meters because we are using the International System of Units. Okay? That was the question of, let's see who, yeah, that was Alexis' question, right, Alexis? Makes sense, Alexis? For the diameter, is the unit of length. Okay, for the density is the unit of kilogram per cubic meter. Now, the key here is what's going to be the units for the volume, right? Now I want you to answer this question. Think a little bit about that. The volume of this sphere, right? We have you can even look at the formula here, 4/3 of pi r cubed, right? what you have here is diameter divided by 2, which is radius, right? So you have the radius, the unit of the radius to the cube. What happens to the unit of meter? If the diameter is meter and we are cubing a measurement in meters, what's going to be the unit of the volume? Right? It's just a regular. There's a name for that, right? No, it's just regular algebra, right? It's just regular algebra. You have diameter in, yeah, Vanessa, yeah. But I want you to report it in a slightly different way, okay? I want you to learn how to report that unit. Everybody understand why is cubic meter? That's the unit of volume, right? The unit of volume is cubic meter, centimeters to the cube. You can also put cubic feet, right? But we are using the system, international system of units, right? So you're going to type M3, right? And then what else are you going to do? To make it look nice, we are going to make this 3 a superscript for the meter. And now we have, I don't want the 3 italicized. I don't think it looks nice. Now we have the unit for the volume here. And you can do the same for the other ones. Okay, copy and paste. Oops, what did I do here? Yeah. No, I'm going to cubic meter. I'm going to italicize. You need to do that in every spreadsheet that we work with. Oh, did I do that? Oh yeah, this one I got it. Good. This next one here. Just practice, highlight the cube. I don't want it italicized because it doesn't look nice. Click on font and superscript it. Make it look nice, professional. Okay. And let's see if you have any other units that we have to deal with, right? There is no units here in this table, okay? But there are units here. You're going to report the slope, the unit of the slope. You're going to report the unit of this number. That is a percentage, okay? We're gonna get to that later on because you still do not know what the slope that you're reporting there, how you're getting the slope, okay? So now let's go back to Camden's question, right? You were saying that whenever he put it, what Camden said? Camden said that if he put here in a numeric format, number, right? Instead of scientific, you put in a numeric format, what does he get? He gets the number 0, right? That's what it looks like it is, yeah? But if you click in the cell, you can see that's not the number 0. In my case, it's point, if you look here at the top in this bar, you see that's not 0, it's 0.013.
Oh.
Okay, but it's reporting as 0. Why is it reporting as 0? There's a reason why it's reporting as 0, right? Think about that. All right. Here you go. If I click in the one there, then the whole number shows up, right? Think about that. And very soon I'll give you the answer. Otherwise, I'm going to spoil the fun, right? Okay, the reason is that Excel is rounding this number, down, okay? And why is it rounding this number down? It's rounding this number down because it doesn't display all the decimals, just like Ridwan said, right? So we have to continue changing we have to continue to change the format of that cell. Right now, that cell is in numeric format with 0 decimal places. If I put only 1 decimal place, it's still going to show 0. See that? Here's the sample. I'm gonna click it here. Now it's still 0, but now it's a 0 with 1 decimal place, right? Let's keep on going. You know, because remember, the resolution of the ruler is 1,000 of a meter, right? So you have to have how many decimal places there? Because the resolution is 1,000 of a meter. It's not set to display any decimals with the values given. It's best to go up to at least 5 decimals. Yeah, gotta be careful, Ridwan. Gotta be careful. Gotta be careful. You have to display the proper number of significant figures, right? The proper number of significant figures. We are using the ruler. The ruler, recall, has a resolution of 1 millimeter, right? 1 millimeter right in here, which, by the way, can be written down. I'm going to write it down, 0.001, right? In meters. Oh, wait a minute. Did I put 0.1 millimeters? No. It's supposed to be 1 millimeter. Why did I do that? Gosh, should be 1. Yeah, for some reason I did that. I don't know why. Maybe I was talking about some other. Okay. It's not 5, so it's not 5 decimals, right? It should be 3 decimals for the ruler. That this one here should be what? 4 decimals for the vernier caliper and 5 decimals for the micrometer. So it's 5 decimals for the micrometer. Make sense now, Ridwan? For the ruler is 3 decimals for the ruler because the resolution of the ruler is 1 millimeter. For the vernier caliper is 4 decimals, micrometer is 5 decimals. And now we can go back to my spreadsheet, right? And put 3 decimals there. I have only 2 decimals. Format cell, add a 3rd decimal, and now you have the proper number of significant digits. Even though you have 3 decimals, okay, the number of significant digits in this case is only 2. 1 and 2. 0 to the left of a significant digit is not considered significant, but 0 to the right is considered significant digit. That's a rule that we use for significant digits. So let me write it down here, this rule, okay. Rule for sig figs, right? Significant digits for the digit 0. Okay, 0 is considered a significant digit whenever it is located to the right of a significant digit, the right of a significant digit, the right of a non-zero significant digit, to the right of a significant digit. Let's put here. It doesn't have to say non-zero. To the right of a significant 0, or whenever it is in between 2 significant digits. Okay. Zeros to the left of the leftmost significant digit is not considered a significant digit. Okay. Important rule, I want you to memorize it. Don't forget, number of decimal places is not the same as number of significant digits, not necessarily. Here we have 3 decimal places, but you have only 2 decimal places. And that's something I'm gonna write down here too. The number of decimal places in a measurement or result is not necessarily the same as the number of sig figs. Okay? In the measurement example, right? Example. In the measurement 0.013 meters. Okay, come on. I put meters here. Oh, yeah, it's typing here. In the measurement 0.013 meters has 3 decimal places and but only 2 sig figs. Furthermore, the zeros to the left of the sig fig 1, comma, are not considered significant digits. What time is that? 9:46. Okay, let's play with the other ones. I'm gonna give you only some samples here to work with. Okay, I'm gonna do for the vernier caliper now. Vernier caliper has a different resolution. Vernier caliper, the measurements in vernier caliper is supposed to be reported up to the 4th decimal place. Just like I wrote right in here. Okay. Just like I wrote right in here. So here you go. One, two, three, 4 decimal places, right? Go back. So there are 2 format changes that you have to make. The first format change that you have to make is from scientific to numeric format. The second format change that you have to make is the number of decimal places. 1, 2, 3, 4. And now you have the right way of reporting a measurement. See that this measurement here has a 0, which is a significant figure, but the other 2 are not significant figures, right? So let's, in the following measurement, right? Another example. The measurement 0.0170, the measurement 0.0170 meters. Measure with the vernier caliper, comma, is supposed to have 4 decimal places, right? And but only 3 sig figs. You know, the zeros to the left of the leftmost sig fig, which is 1, right? And I have to write that in the previous one as well, are not considered significant digits. I'm going to write it here. The zeros to the left of the leftmost sig fig 1 are not considered significant digits. 950. So I want you to continue working here in this. And then, right now you have enough information, you have enough knowledge to do only those, to adjust only those significant digits, right? Because I still didn't tell you how we report the significant digits of measurements, right? So work on those right now, right? I'm gonna write that down here for you. Right now, you have knowledge to report the sig figs of the diameter and masses of the diameters and masses, the plural, right? Only. In order to report the sig figs, SF, sig figs of the volume, you need some more information, right? But right now you should have plenty of work to do, right? Work. So for now, for now, work on the sig figs, of the diameter and mass, of the diameter and masses. And masses. So, so let's go. Units first, right? Tessa, do you manage to fill up the units so far?
I'm still working on it.
Working, okay, on the units, okay. Don't forget, fill up the units only for which tables? Fill up the units only for this table here. Table 0-2. My number is 0-2. We worry about the units of the other tables later on, okay?
Okay.
Very quick to do that. Work only in the units of table 0-2. We worry the units. We worry about the units of the other tables later on. Okay. So summary, right? 1. 2. 6 figs, diameter, and mass only. worry about the units. You worry about the sig figs of the other, of the volume of the other parameters later on. 9:54. I want to have a break right now, right? Any questions? Yeah, let's have a break. 9:55, and then we continue the next 15 minutes. 10 a.m. Okay.
Professor, can
Yeah.
you show us how to get the subscript for the units once again?
Yeah, let's do that. Here you go. Here you go. I'm going to erase it, right? Meter 3, right? You want the 3 to be superscripted, right? You want the 3. The first thing that you do, it's not, what do? You highlight the 3 right here at the top. See that? When I click, when you type M3, this M3 shows up here at the top of Excel. What do? Oops. You highlight 3, right? Right click on the highlighted text. This window, this drop down window shows up, and then you're gonna have format cells again. Format cells again, okay? This format cell can be used for all sorts of things, right? One of them is to format the font, okay? You can use all sorts of fonts, but let's leave New Roman here. And then look here, you have strike through, you have superscript, and you have subscript. See that? You can also have boldface, italics, normal, and so on. Okay, this one for some reason is in Portuguese. I don't know why, But those are in English. Okay, superscript. When I do that, here you go. The superscript format for the 3 is applied. Only for the 3 because I highlighted only the 3. Makes sense? Try that. Try to do that on your own. Keep on pressing. You're gonna be using superscripts, and maybe even subscripts. See that this R square is a superscript. This square here in the L in the R is a superscript. Okay. Any more questions?
Yeah, how did you do that for the sphere 1 diameter? Because I don't know if it's on superscript too.
Is sphere 1 here?
Yeah, the diameter for that one, because it's a different format than all the others.
But which cell are you talking about? Which cell are you referring to?
The 0.013.
Okay, there is no superscript here. You don't use superscript here. Superscript is just for the meter, the cubic meter, right? Cubic meter is the unit of volume. So you don't use superscript here. You just live in the normal format. Okay?
Do we have to change those for all of them?
Oh, you have to change. What do we have? Oh, here you go. Yeah, you have to change for all of them here. Yeah. You're not gonna do superscript here. What you're going to do? You're going to display the proper format, right? I'm gonna do that again. Here you go. This cell here, right? Right click, format cell, but then I'm not gonna change the font. I'm gonna do something else. Okay? See, I have all those choices here, all those tabs. See that? You're gonna go straight to number, and you're going to change from scientific to number, right? Make sense?
Yeah.
As a last step, you have to add decimal places to display the proper number of sig figs. 1, 2, 3. If you do that, now you have, voila. You change the format from scientific to numeric, and then you also added decimal places
Okay.
to the number. Okay? It's the same thing for the rest, including here, right? Including here, but don't forget This one must have 5 decimal places.
The mass?
Yeah, the mass has 5 decimal places. Let's go back here to the note. Here you go. Writing, where's that? Right here. See that? The mass? Scale.
Yeah, thank you.
Okay. I'm gonna put it here. Length, right? Length. Ruler. Vernier. Caliper. Micrometer. Mass. Scale. And okay, now we delayed our break, right? A few minutes, just 5 minutes. Let's change it here. 10 o'clock a.m. to 10:15 a.m. Any more questions before we go? We save it here. And now we can pause, stop sharing, pause. I am back here. Were you able to work on the units and the sig fix? Let's go one by one. Just want to see where you are. Let's say units, right? Destiny, were you able to work on the units? Units is the first one, right?
Yes.
Yes, okay. Any questions, Destiny?
No, not right now.
Okay, and the other question is the sig figs. Oh gosh, figs. Let's see, were you able to work on the sig figs?
Yes.
All of them?
Not all of them, but
Okay, but you're working, okay. And what about Tessa? Hi Tessa, were you able to work on the sig figs?
Yeah, I've been working on them.
Okay, did you finish everything?
Not yet.
Yes, okay, answer yes. Okay. Now, Gael, did you work on the units and the sig figs? Let's see. Gael there? Okay, looks like it's not answering. And the question is, did you work on the units and the sig figs? Yeah, everything? Everything that I asked, you did it? Okay, let's go next. Read one. Any problems there? Did you work on the units and sig figs? Okay, Ridwan, are you there? Sorry, I just stepped away and got back. Okay. Can you repeat the question? If you work in the units and sig figs, did you finish all of them? In table, yes. Okay, yeah, you're supposed to fill up all those units, right? And work on this sig figs here, display them properly. That's what you're supposed to do. Yeah, in table 0-2. Okay, good. And next. Next is Ashley. Same question, Ashley. She working on that? Okay, what about the units? Units you finished, right? Okay, good. So Annabelle is here.
yes.
Okay, so let me give you attendance here. So did you manage to work on the units and sig figs?
Yeah, I'm working on that right now.
In the sig figs or in the units?
The sig figs.
Sig figs. Okay, so you finished the units and you're working on the sig figs. Okay.
Yes.
And by the way, there's a little trick to do everything at once. Okay, I didn't tell you that. Let me, instead of going one by one here, right? You already know that because this is a ruler, every measurement that you have here, every measurement that you have here is going to have 3 decimal places, right? So there is a quick way of doing it everything at once without going one by one, okay? I'm gonna show you now, what do? You highlight only for the ruler, the measurements only for the ruler. Right click, format cell, change from scientific to number, right? And then adjust the decimal places here. And it's gonna do everything at once. It's gonna do everything at once. Okay? That's a shortcut. Then you're gonna go for the vernier caliper, right? You do the same thing that you did for the ruler. Highlight everything, right click. Those are the little tricks, right? Change from scientific to number and adjust the decimal places. Instead of 3, in this case, it's gonna be 4 because the vernier caliper. And you do everything at once. For the micrometer, same thing. Right click, right? Format cell, number, and how many? 1, 2, 3 for the ruler, for the vernier caliper, and for the micrometer. Micrometer is 5 decimal places. And bingo, you got the right number of sig figs here. And finally, for the mass. For the mass, go back to the resolution of the mass, right? Of the scale. The resolution of the scale should be, 2 significant figures whenever it's in grams, should be 5 significant figures. 2 decimal places whenever it's in grams, 5 decimal places whenever it's displayed in kilogram. And you go. So you have to have 5 decimal places here. Format cell, right? Scientific change to number, 1, 2, 3, 4, 5. Much quicker, right? In this case, we can do that. In certain cases, you won't be able to do it. But for those specific measurements, yeah, you are able to do that because all those measurements are measured with the same instrument, right? All those 6 measurements are measured with the same instrument. And then here too, all those 6 measurements are measured with the same instrument as well as here. That's why you can do that instead of doing one by one. Changes the order? What do you mean changes the order? Explain that to me. You might, let's see, do you want to share your screen, Ashley? It's going numerically from highest to lowest value. Okay, show that to me in your, I never see anything like that. I'm gonna let you share the screen, okay? And then you show me the step by step so I can understand what the problem is. I'm gonna allow you to, do you know how to share the screen, Ashley? Oh, I was doing it wrong. Oh, okay. So I figured out. Okay, thank you. That's the nice thing about those Zoom meetings, right? You can share the screen, I can share my screen with you, you can share my screen with me. And then if we add something else like AnyDesk is a software, maybe you're familiar with that. I can operate your computer remotely, and if you allow me to do that, right? And if I allow you to do that, you can operate my computer remotely too. That's how far we have gone. Back in 1992, when I was working at NASA, we didn't have those softwares. We had computers, right? Much older computers, but we didn't have this type of software. But I still remember operating one device there at NASA. I was in a desk, the device was in another desk. I was just operating the device from my desk, instead of being far away there in the table that didn't have any chairs. I was in my own table and I was operating this device that was connected by a cable, just like astronauts operate the Canadarm, right? The Canadarm that they have there at the space station. Remote operation. So now we can do that at no cost whatsoever. It's amazing how far we have gone. Okay. Now let's worry about, let's see, did I get everything that I want? I think so. Yeah. And now we have to talk about significant figures of measurements. 1025. I think we'll be able to finish it. Okay, let's see. Now, significant figures of measurements. Significant figures of results, right? What's giving me this? Okay, Italian language. I don't need Italian language here in my computer. Okay. Significant figures of results. Okay, we're going to start with the easiest one. Okay, there are two different sig figs rules. There are two different significant figure rules. One for multiplication and division. Okay, you're gonna put like that. And two, another one for addition and subtraction. Right? When you operate in your raw data, let me see, Eric is having a problem. I can't seem to drop the Google Drive file into Excel. What are you trying to do, Eric? Are you trying to, you want to do the opposite, right? You want to drop the Excel file into the Google Drive folder. Is that what you want to do?
Yes.
Okay. Okay, let me check if there is any problem. What's your group number? What's your group number, Eric? Let's see. Eric, Eric Martins, your group number 5, right, Eric?
Yes.
Okay, so you're trying. Let me confirm with you. You have a. That's not what I want. You have a Excel file in your computer, and you want to drop it into Google Drive, into your folder in Google Drive, right? That's what you want to do.
I'm trying to get the data from this week's lab to drop it in Excel.
Oh, no. Okay. The way you do it is different. Okay, so that's not how you do it. The way you do it is far simpler than that. Okay. Your group number 5, right? Here you go.
Yeah.
Here is the file, okay? Here's the file. You see this file there in your group folder, right? So what you want to do, you want to download this file, right? That's what you want to do.
Yeah.
Okay, so all you have to do is right click, download. Okay? Click, right click, download. And here you go. Your file was just downloaded. This Excel file was just downloaded to my hard drive. Okay, if it is located, in this case, it is located in the download folder. Did you try that? And if you do that, you don't have to type the numbers there. The numbers are already in the spreadsheet. Okay, here you go. Don't forget to enable editing, in case it shows up there. Is that make sense? Is that resolved there? Okay, but okay, so if you still have any problems, you get back to me. Okay, I want to continue talking about the results, okay? Two different ways, two different significant figure rules for results, okay? Let's say one, if you are multiplying or dividing two measurements, right? Two different measurements, right? Two different or same measurements. You report the final result with the least number of sig figs between the measurements, right? I'm gonna give you a, this is the easiest one. The rule for multiplication division is the easiest one. Example. Okay, example. I'm gonna give an example that is in your spreadsheet. Go back here to my spreadsheet. That's the sample. I'm going to use the sample spreadsheet. Remember, I want to display the proper number of significant figures of those three columns. Okay. The first thing that you have to know the formula. Okay. Example. So I'm going to do for consider the measurements for the diameter of the spheres made with the ruler. The measurement, okay, not measurements, but the measurement, let's see, I'll get this one right in here. 0.016, right? 0.016 meter for the diameter of the sphere made with the ruler. How do you report? How do you properly report the volume of this measurement you made, okay? And then I'm gonna solve here for you. The first thing that you have to know is, oops, where are the equations? Here you go, equation right in here. It's the volume. The equation for the volume, right? That's the first thing. And it's already spelled out in your spreadsheet. 4/3 of pi times the radius or the diameter divided by cube to the cube, okay? 4/3 pi, and I'm gonna put the formula in terms of the diameter, right? Diameter d divided by 2, which is the radius, raised to the cube. Okay. Remember, the measurement was done in terms of the radius, right? The actual formula, most of the time we use the formula of the volume of the sphere in terms of the radius, right? But since we are measuring in terms of the diameter, we must convert this equation in terms of the diameter. Okay. So one more step. Will this guy go to the 8 number becomes 8? The diameter goes raised to the cube. And the original formula that what we had, that was 4/3, becomes what? 8 cancels out with 4, becomes 1/6. And now we have the formula in the way that we want, and we can analyze this formula. Okay? This D that we see here, it is as though it's D times D times D, right? D is multiplying itself 3 times. You go. And now we should follow the rule here for multiplication. Okay. The number of sequence figures of D, SF of D is, I'm gonna report like that, subscript is 2. Okay. SF for D is 2. Consequently, the number of significant digits for D, right? D times D times D, D, okay? Should be 2 as well, right? Should be the least of the 3. But they all have the same number of significant figures, okay? This one has 2 significant figures, this one has 2 significant figures, this one has 2 significant figures. Consequently, this multiplication should be reported as 2 significant digits as well, okay? And all those numbers, and by the way, there's another important rule for significant digits. Let me see if I get that here for you. Okay, another rule for significant digits, right? I'm going to document here. When dealing with mathematical numbers, okay, which are not measurements, neither results, their SF figures, their number of significant figures infinite, okay? So what does it mean? It means that the number of significant digits of the number 6 and the number 1, right, is going to be infinite. Since those are not measurements, but just mathematical numbers, right? And including the pi, not just those. That's another important rule. Mathematical numbers which are not measurements, nor measurements, either. Have an infinite number of significant figures. Better, right? Okay, so let's finish this one here, right? We want to find out the number of significant digits of the volume of this measurement. And I just discovered that should have only 2 significant digits, right? Let's go back to the spreadsheet here, the sample spreadsheet here. This number that you see here right now is being displayed just with a single significant digit. The power here is not considered significant digit, only this one here. And notice that 10 to minus 6, right? So I'm going to display it with two significant figures. Right now you have only one significant figure. So all I have to do, I have to add a single decimal place to this result of mine to display it with the proper number of significant digits. That's the rule. This measurement has two significant digits. Consequently, this result must have two significant digits as well. Okay, if you want to put that in numeric format, you can too. It's possible, okay? But let's see. You have to keep on adding, right? See that? The number that's going to display there in the spreadsheet is going to be exactly this number here. Because the 10 to minus 6 number, you still have 0.00, right? 3 decimal places, you still have 0 significant digit, 0 significant digit, no significant digit, no significant. Oh, now we have 1 significant digit. We put enough decimal places that the significant digit start to show up. And one more decimal place will result in two significant figures. That's another format. You can put it either the numeric format or the scientific format, right? So here you go. I prefer to put that in scientific format. And there's a reason for that. I prefer to put that in scientific format because it's, it's too difficult to read the number with so many zeros here to the left, okay? It's too difficult. So if I were to, for the sake of good practice, what do? For the sake of good practice, we return that value to the scientific format and put just one decimal place to display two significant digits. Okay? Either way is correct. I'm going to copy that and let's see, I'm gonna paste it. Yep. Hey, this guy. Maybe I can do it here. Let's see. I want to copy and paste here in my example. Or yeah, I got it. And here we go. The way we do it is like that, 2.1. Not this one. I'm gonna make it nicer. Takes time to do that, right? So that's what discipline is all about. Discipline is about taking your time, put everything in a nice format. It might seem, unnecessary, but it's not. And let's not forget that's how that measurement is supposed to be reported in here in this Word document. In the spreadsheet, you just report this number, right? And you don't need and the cubic meter is already reported that at the top. Okay, and how do they report that in Excel? Excel has a different format, right? Let's take a look again at Excel's format. E minus 0.6, E minus 0.6. That's what the E, oh gosh, so bad, right? I cannot do much. That's the format of Excel. Don't forget that this guy here is, let's put a parenthesis. That's Excel format. That's the regular format that we use in the paper. For some reason, Excel decided to use the power of 10 as E, letter E. Okay. And now you can do one by one. Sometimes, let's see if, here you go. All of those are going to have two significant figures. Do you see that? All those results here that you see right in here is supposed to be displayed with two significant figures because all those measurements has two significant figures. So let's do that all together. Here you go. For this specific spreadsheet that I'm using, and you have to adapt this knowledge to your own set of measurements. Okay. See here, I'm going just to report one decimal place, which is supposed to result in two significant digits. I do everything at once. Don't need to keep on, hunting one by one. Don't need to keep on doing one by one. And then you do for the vernier caliper, right? In the case of the vernier caliper, we're going to have one additional significant digit, or consequently, we must have two decimal places here if you live in the scientific format. 1, 2. Two decimal places for three significant figures. And here, 4 decimal places for, let's see, 2 decimal places for 3 significant figures, 3 decimal places for 4 significant digits. Four. See, we have a 0 here. This 0 here is a significant digit because it's between 1 and 7, between 2 significant digits. Okay. So at this point, you should have completed the units and significant digits of table 02. Right now, not you should have completed. By now, you should have all the knowledge that you need to complete table 0-2. Okay. By now, you should have all the knowledge you need to complete the units and sig figs of table 0-2. We are almost there for another break, right? Our previous break ended at 10:15. We can go for another 10 minutes. And let's see how we're doing there. And notice that I gave you the rule only for multiplication and division, right? I will give you the rule for addition some other time.
Professor, sorry, what was the decimal places for micrometer, roller, and vernier?
Okay, so here you go, right in here. Where is that? Okay, where did I put it? Okay, ruler, 3 decimal places. Vernier, 4 decimal places. All of that in meters, right? 5 decimal places. 3, 4, and 5. And the scale 2 is 5 decimal places. Okay.
Okay, got it.
Okay. And let's see if I can. Okay. Rules for significant figures, right? We try to summarize the rules for significant figures so far. Summarize rules for sig figs. Summary. Figs for the ruler. No. 3 decimal places. Places. In meters, right? Sig figs. The vernier caliper. You know, I want to give a more generic rule. Here you go. Sig figs for any instrument, okay? Report the measurement up to the resolution of the instrument. Okay? And so, ruler, 3 decimal places, right? Vernier caliper, 4 decimal places. Micrometer, 5 decimal places. And the scale that we use, the scale. Ooh, scale, 5 decimal places, but the unit is gonna be in kilogram. That's the generic rule. Those are examples of the generic rule. Generic rule, right? What else did I wrote that down? I'm gonna try to put everything in a single place so you don't have to keep on hunting it, right? Here you go. Significant summary. I'm gonna put it bold-faced. Rule for significant digit for the digit 0. 0 is considered a significant digit whenever it's located to the right of a significant digit. Or whenever it's in between two significant digits. Zeros to the left of the leftmost is not considered a significant digit. Okay, example. Okay, and then here, examples. I'm giving you examples. Examples. 0.013 meters. That a measurement made with a ruler, right? Okay. Zeros in bold face are not significant digits, significant figures. Okay. Now, zeros zero, just a single zero, right? 0 in bold face is a significant digit. Is a significant digit or figure. And let's do one more. Let's put like that. 0 in bold face is a significant digit or figure. What else? Okay, and then we have the significant digit for results, right? This is significant digit for measurements. Significant digits for results. Multiplication and division between measurements. The measurement with the least number of sig figs dictates the number of sig figs of the final result. And I came up with an example here. Example right here. I'm not gonna paste everything. I'm just gonna paste the final thing here. Here we go. Example. Measurement. Diameter of the sphere D equal to the volume, the correct number of sig figs of the volume of this sphere should be 2 as well. Or the right way to report it would be like that. Oh, I should put that one too, right? When dealing with mathematical numbers. One more rule of significant digits for numerical values. For rule of significant digits for mathematical values. Numbers, right? Which are not measurements, nor results. They are assumed to have an infinite number of significant figures. Okay. So example, significant number of significant digits of the number of the digit 6 or the number 6 should be equal to the number of significant digits of the digit 1, which should be equal to the number of significant digits of the number pi, which is equal to infinite. This one stays here. We're just putting in a single place the rules for significant digits. Okay, example, I don't need that anymore. 1059, right? We have all those rules so far. I didn't exhaust them yet. We still have to go for subtraction, addition and subtraction. We didn't do that yet. It's a little bit more difficult than the other one. Okay. And 10:59 as well. Let's see, let's take our break. Any questions? 11 a.m. to 11:15 a.m. Ui, tava lá fora? Ok. Okay, any questions? Okay, so let's take our break now and I'll see you shortly. I am back. Let's see. Thank you, Ridwan. Thank you, thank you. And that's what we have so far for the summary of the rules of significant figures. For significant figures. Let's not write down summary. Just in a single place, right? So you don't have to go everywhere. 1. Okay. 2. 3. Okay. 4. Let's see if I can do it. This one goes here a little bit here. This one goes a little bit there. See? No. Oh gosh, no. Like that. I'm gonna cover that. I'm not gonna cover that yet. Okay, because we don't need that yet. And example. 1, 2, 3, 4. 1, 2, 3, 4. I don't like this format. Let's see. I'm gonna put like that. Okay. Okay, okay, okay. Okay. Here you go. Nope, don't want that. Make it look nice. What's that? Oh, this example here is supposed to be elsewhere. Okay. See, if I don't go through that, I don't notice it. Here you go. Example. Example, example. And this one goes here. Okay. 1, 2, 3, 4 with examples. Okay, and what we're going to do now? Okay, now we're going to do the fun thing. Now we're going to do plots. We're gonna come up with plots of the graphs. Okay. So you can see that my table is in good shape, right? So now what we have to do, going back to the notes here. Oops. Next step is to plot our graph, okay? So what we did, we worked on the units, on the sig figs, and now the next step is to plot our graphs. There are going to be 3 graphs. 3 graphs. Okay. Just recall what we're going to do. We have the volume, right? And what are we going to do? What are we going to plot here? This experiment was designed. Okay? This experiment was designed to determine experimentally the density of the steel spheres. Okay? In order to do that, we did the following. One, now to match the density of these two experiments, the density of these two spheres, and compare, to determine and to compare this experimental density to the theoretical one. In order to do that, we did the following. One, we measured the diameter of the spheres. Okay? We measure their masses. And three, calculated their volume. That's what we did. And recall that the equation for density is, what's the equation for density? Get it here. I'm gonna use this thing here. Oh, go. Remember the equation for the density? Density is usually represented by the Greek letter rho. And the density is what? It's the mass divided by the volume. That's the equation for the density. So we have mass, we have a volume. We measure the mass, we calculated the volume. We still don't have our experimental value for the density. How do we find it? Okay, the way to find it is a very simple one. We have six measurements for the mass, right? We have 6 measurements for the mass and 6 results for the volume, each corresponding to the 6 different spheres. Okay? Okay, now notice that there is an interesting relationship between those terms, and what can I do with this relation? I can do the following. I can rewrite this relation as being mass is equal to density times volume, right? This is a measurement, this is a result. We still do not know what would be the experimental value of the density. How can we find out that experimentally? Okay, there's a very simple technique. Okay, you can consider this relation as being something like that, you know? Here's a y variable, here's your x variable, and here is a slope of your equation, okay? Since we are using the same material in our measurements, all of them are still spheres of the same alloy, this value here is supposed to be the same, even though the mass and the volume are different. So we can treat this relation here as though it's a linear equation. Okay? In the above, B has 6 values, M has 6 values, but the density rho has a single value because we use the same material, a steel sphere, for all the measurements, okay? So what are we going to do? What are we going to do? Okay, answer. We are going to plot M along the y-axis and B along the x-axis. if we did everything right, you know, if your data is good enough, we're going to get a straight line where the slope coincides with the density. Okay? That's one very good experimental technique to obtain the density of the material. And now we are going to do the plotting. Notice that so far we didn't do any plotting, right? But now we're going to do that. And that's the fun part. We are going to find, we're going to plot a graph for the ruler, right? Using the volume obtained with the ruler. We are going to plot another graph with the volume for the caliper, and we're going to plot a third graph for the volume obtained with the micrometer. Let's do that together. Let me know if you have any problems. I'm going to highlight the mass, and now see if you can highlight the volume of the ruler separately. There's a little trick here, okay? There's a little trick to do that. And I want you to do that. And here you go. I'm gonna plot this graph, insert, chart, always scatter plot. Never connect those dots with a line, okay? Does it look like a straight line to you? Does it look like a straight line to you? Yeah, right?
Yeah.
Okay, so let's see if we get a good, remember, this is an actual experiment. Those are actual experimental data. I didn't change anything there. My students collect those measurements in the lab for me. And now I'm sharing that with you, right? So here you go. I'm going to click one of the data points, right click it, add trend line is going to be a linear because it's very close to a linear. Display equation on chart, display R-square value on chart. Okay, so that's what I get. I don't like this title chart. I remove it. So look what I have. I have here is the mass along the y-axis. Here is the volume along the x-axis. Okay, here we have my slope that was obtained from the experimental data, which, by the way, should coincide with my density. And because we're dealing with experimental data, we always end up getting a intercept value there, right? Remember, this is real life data. Real life data never get exactly your mathematical result, never. And also we have my R-square, right? I want you to do that for all the three graphs. There's more things that you have to do here. Okay, I'm gonna show you very soon, but do that for the ruler. This is for the ruler. Okay, notice that, let me going down here. I'm gonna zoom out. When I click on the data points, see what happens. All those two columns are highlighted, right? So you know where the data came from. So you know where the data came from. Mass, volume. And now you have your first slope that you're going to compare to your data, that we got in the literature. Well, where is my, strange. Okay, something happened here I don't quite understand. Why is that? Oh, that's because I erased it, right? You remember the value that I got, which was what, 7,050, I presume, right? I think that was 7,050. Yeah, I had written down the limiting values of the density here, and I accidentally deleted, and I lost the value. So what are you getting? Here you go. Here's your theoretical value, and here's your experimental value. It's good enough? It's close enough for you? 6,900, 7,050. Okay, we are getting what? 150 difference. Okay, 150 difference. Because this is the slope, the unit of the slope is going to be what? The unit of the vertical axis divided by the unit of the horizontal axis, right? And we didn't finish yet. We didn't finish yet. We got to put the, don't forget, we have to put the chart elements there. Axis title, primary vertical, right? This will be volume, V, meter, cubic meter. You know, we can do the superscript just like we did before in Excel. Where's my font? Writing here, superscript, good. And I like to do that as a boldface. And then we gotta do the vertical.
Wait, Professor,
Yeah.
that's the
X-axis
title?
Yeah, volume. It's the volume. The x-axis is this column here.
Oh, I mean, I'm talking about how do you insert the titles from bottom side.
Well, here you go. I'm do that again. We're gonna do it again. Here you go.
Okay.
Well, first thing you gotta tell me whether you have the graph or not. That everybody has the graph before we move forward, right? Let me check with everybody here. Okay. Six figs. You know, graph. Now I'm gonna go through everybody.
Oh, I have everything too.
Because it's crucial. Okay, but let me ask everybody else, okay? Do you have the first graph, Tessa?
Yeah, I have it.
Okay, good. Destiny, you have the first graph?
Yes.
Okay. Okay. Gael, do you have the first graph? Thank you, Ridwan. I'll correct that. Gael, do you have the first graph? Yes, good. Ridwan, you have the first graph? I presume you have, right, Ridwan? Yeah, he's a little bit slow here. Sort of trying to fix it as an input some data. Okay. And Ashley, do you have your first graph? Yes. Annabelle?
Yes.
Did you have any problems highlighting the volume? Sometimes students have difficulty highlighting the column for the volume. Did you have any problems doing that? No, there's a little trick to do that. Since nobody complained, I presume that you had no problem doing that, right? I see Norberto, did you plot your first graph?
Yeah, I did them.
Okay. Vanessa?
Yeah, I plotted it.
Okay, good. Camden?
Yes, I did it too.
Okay. Victoria? Victoria, are you there? Victoria. I don't see Victoria here. Yeah. 13. Oh, we have two students missing, huh? I'm gonna put a star here in her name. Well, even better, I'm gonna put it here. Alexis, did you plot your graph? Yes, good. Marco Daniel Sanchez. Good. Sky.
Yes.
Good, thank you. Eric Martinez, did you plot your first graph? Eric Martinez. Eric is here.
Working on.
Yeah, you're working on that. Okay. And Catherine, did you plot your first graph?
Yes, I did everything.
Okay, good.
Oh no, I thought that was Camden.
Who is that? Mention your name, please.
Oh, that was Camden, the one that I said yes.
I'm sorry, Canvas? Let's see.
The Camden said yes to Pacheco, I think.
Pacheco. Okay, Catherine.
Yeah, I didn't mean to say that.
Okay, Pacheco. So, okay, I don't see. And who's talking? Who are you? Are you next to Catherine or?
I think Catherine didn't respond.
Isn't responding? Yeah, I need her to be logged in. Okay, log it here. So, are you in touch with her?
No. I didn't mean to say yes.
Okay, so I'm gonna put here a star. Okay. I'm gonna put Annabelle and Rodrigo. What I'm gonna do? It's better if I put alphabetical order here. Sometimes it's difficult to keep track of you folks whenever I have it just in group name, group number. Okay, now it's alphabetical order. Good. So let's continue with the graph, right? We go. What I did here? Okay, let's try. Let's do it again, right? Click on the graph, okay? Camden was asking that, right, Camden? Click on the
Yes.
graph.
Mm-hmm.
Whenever you, okay, if you unclick the graph, watch what happened here at the top. There's nothing here at the top, right? On the right top. Right. But if I click, then all those two options shows up. Chart design
and stuff, right?
Chart design, add chart element, X title, primary horizontal, and then primary vertical, okay? Primary horizontal is volume, cubic meter. Don't forget to superscript this font. Boldface. Here should be what? A mass, right? Emma. And then you put between parentheses kilogram. You know, or boldface. That looks nice. What else can we do to improve this graph? Okay. That's other thing that can. I like those Tyroxes. Tyro in a larger font. You know, so let's see what font we have here. I have 10 size. Wow. Use at least the 12 size, okay? Let's put this one 16. Let's see how it looks like. It's trying to look, it looks like it's too large, right? Let's go back to 14. 14 must be a better size for this font. Okay, this one here, huh?
Oh, I'm sorry. I forgot how to. I mean, I don't know how to do the uppercase one. The
Superscript.
Superscript. From there, yeah.
Highlight the number. Highlight the number. Right. Right click. And font.
Oh, font. Okay.
Font. And then, you know, there is this option here for superscript, and double strike through, and so on, right?
Right. Thank you so much, Professor.
Okay. You do this one for 14 size as well. 14 size, don't make it too small. 1139, right? I want those numbers, you know, those numbers should be font 10 right now. It's too small. Let's do larger, 12. Use at least 12 font size. Okay. Everything here is in scientific. See that? You can start to see that those numbers are becoming too close to each other. So I recommend when something like that happens, I recommend that you cut down the decimal place here. You don't need this decimal place. And the way you do that, right click, right? Format. Let's see, format font, I believe. Let's see, format axis, must be format axis. Yeah, format axis. When you format axis, this pane here on the right side shows up, right? And you go to number at the bottom. Decimal place, there's just one decimal place. You don't want one decimal place, you want 0 decimal place. And now it's more compact. Okay? There is a little bit of blank space here that you can take advantage of. How do you fix that? Remember, you don't want large blank spaces in your graph, right? So we can adjust this scale. Instead of starting from 0, we start from 1. Okay? Here you go. 1. Right in here. 1 e minus 6. Here you go. Adjusted. Do the same for the vertical. See, you have this big blank area here. Double click here. You want to start at 0.005. Minimum 0.005. Okay, and now we're minimizing the blank areas in the graph. I still didn't. I can do something else here to this axis. Do you see how many zeros we have that we are not using? We don't need all zeros. 1, 2, 3, 4, 5. We need only 3 decimal places here. Okay, so just like before, right click, right? Format axis. Let's see, format axis. Let's go down. Is that here? No, that's not what it is. Okay, format the numbers. Yeah, that's the one. We are in the axis options, right? We want to go to number options. Number options. Right now we have 6 decimal places. You want only 3. And what else do you want? You want to increase the font size to 14 as well. Hopefully I'm not going too fast. Huh? 14 or 12? 12, right? And Ridwan sent me a, oh yeah, 7,900, right, Ridwan? Let me fix that. I put 7,900, okay, good. And now we have our first graph. It looks good. Oh yeah, it looks like we can remove this blank space as well, right? Yeah, let's go 0.45 all the way up to 0.45 instead of 0.5. Let's see if it looks good. Yeah, somewhat good. I wouldn't worry about this one. I wouldn't worry about this blank space here. If you're going to, adjust the scale, you'd have to put another decimal place here and the number will be too much close to each other, So I'll leave this way. And now you have your slope for your first graph. That's just your first graph. 15 minutes to go. What we're going to do now, okay, you're going to get this slope here of your first graph, 6918. You're going to go down here, the slope. See that? Last table. Type the value of the slope. Oops, what's going on here? The value of the slope that we got in that graph. Why didn't copy? Let's see if it's going to copy it. Doesn't copy. Huh? Looks like I have just to memorize it. Let's see if it's going to copy it. Okay, it copied. Now it copied. Good. Now, what's going on here? Okay. The moment 6918, huh? I'm going to type it. 6918. The moment that I type this slope, now I got a change in the percentage difference. Do you see that? Watch out. I'm going to remove this guy, right? C e times 1 times e to the raised to the second power, right? Go back to that number, right? It changes a little bit.
Professor, mine is kind of different. Mine is it's just value exclamation
The slope
mark.
is different from mine. Is that what you mean?
No, I'm talking about the one that you just typed. What is that called? The quantity ruler, vernier caliper, micrometer units. Slope different. There. I think I don't have any given values. Yeah.
Okay, right now you're working just in the ruler. Let's leave the vernier caliper, the micrometer for later on, okay?
No, I mean like all of them. I don't have the right value, I think. right?
Yeah, but you got this value, right, for the ruler, didn't you?
Oh yeah, that one, yeah, but I'm
Oh,
talking
okay,
about the
okay, we're
second
gonna
one.
get there. You're getting ahead of the okay, you're getting ahead of the game here. Let's concentrate on this one first. There's some other things that we need to do, okay? So now that we have the slope for the ruler, right? You can change the format of those numbers, okay? Format, let's do number formatting, okay? And look what we get. We got a 12% difference between this value and the theoretical value that we found in the literature. Everything here is programmed to give you this result. Now we're going to look for the slopes of the vernier caliper and the micrometer, right? All you have to do is repeat what you did for the ruler. Here you go. Highlight the mass, highlight the volume for the vernier caliper, insert the graph, put the trend line there, display the equation on chart, R squared, and here you go. We're getting a slightly different slope for the measurement of the vernier caliper. Slightly different slope. And I'm going to insert it right in here. 7866, right? No, I didn't copy it. 7866, yeah. Why you didn't copy? Let's see. Let's see if it copies now. Yeah, now it copied for some reason. Yeah. Okay. 7866. And again, just like before, we are going to change the font format. Okay, here we go. Font format, format of the font, number, okay? See what the percentage difference we're getting for the vernier caliper? It's much closer than that for the ruler for some reason. It's either coincidence or is a testament that the vernier caliper makes better measurements than the ruler. And finally, the last one. Don't forget to do the same thing that we did here for this graph, right? For the micrometer. We're running out of time, 10 more minutes to go. Micrometer and scale, insert, chart, right? Here you go. Trend line, display equation. Here you go, 7588 for the micrometer. 7588 for the micrometer, and look at the percentage difference. Okay? It's pretty good. In general, here in this course, anything below 10% is a good result. It's a top-notch result. Anything below 10%. This one is a little bit more than 10%, but don't forget there's a ruler, right? And don't forget, think about making measurements with the ruler of a sphere is very difficult. It's not easy. You may incur in parallax errors. If you're not looking at the ruler in the proper way, if you're looking at an angle, you might not get a good measurement of the diameter of the sphere, right? Maybe that's the reason it's much higher than the other ones that we have here. Any quantities that are in red, just like we have here, see that this quantity is in red, it means that you do not have to worry about significant digits. And it's spelled out here at the top. Quantities in red boldface do not require significant digits or significant figures. And then you have to put the units. Units of the slope. The unit of the slope is what? Is the unit of the quantity in the y-axis divided by the unit of the quantity along the x-axis. Kilogram cubic meter, which is the unit for the density. This formula that you get here for the percentage difference, that's the percentage difference, okay, is exactly the percentage that you're getting. So you're going to put the unit of those values. The unit of those values is going to be the percent sign. I have a funny thing here. Let me fix that. Yeah, strikeout. See, that's not supposed to be like that. And let me make this box look nicer. Yeah, here you go. We almost done. 10 minutes to go. We have the 3 graphs. Okay, we finished table 0-2. We finished table 0-4 too. In most of experience, if not all, you will always get a percentage difference. And that's a good measure of how close your experimental data is to the theoretical data. What's missing now is this other table. What's missing now is this other table, okay? N is the number of data point pairs, 6 for everybody, 6, 6, 6. Okay, let me change the format cell. Number, yeah, number, I don't need, yeah, here you go. What you see, and I don't want boldface here, good. What you see right in here is just your equation. Okay, this one is for the, okay, go, this equation, a Gresham equation. Remember, the Y represents the M, the X represents the V, the volume, V for volume, and I'm gonna write that down. Oh, didn't copy it. Oh gosh, why doesn't do that? Let's try it again. Here you go. Sometimes, let's see. Yeah, sometimes it copies, sometimes it doesn't. Okay, copy and paste here. And then you replace the X with the V symbol, right? Make it look nice. I'm going to italicize. Okay. R square is here as well, 9969, 0.9969. And with N, oh gosh, you gotta increase the number of decimal places here if you want to distinguish that 0.99 from everything else. Okay, 1, 2, 3, 4. Let's put 5. Remember, those numbers, you don't have to worry about significant digits, okay? Everything that's in red. Gotta worry about the caliper. Which one is the caliper? The caliper should be the 7866. This one right here. You know what? Let me see if I can copy everything so I don't have to, go. Yeah, went through. And volume, right? R squared. Don't keep the R squared there inside the box. I want only the numbers. And the last one for the, okay, this one here. Copy. Paste it. Oh, see, sometimes it copies, sometimes it doesn't. Yeah, let's see. Let's try it again. Copy. Let's see, copy it now. You didn't copy. What is that? Huh. Copy. Let's see. Okay, now it's copied. When isn't that? This one, copy and paste here. My equation changes the X to V, right? Italicize the V so it looks nice. And we need 9974, 0.9974. What's the 16 font size? Font size 60. Okay, make everybody looks nice. Okay, and then finally, I want you to do the CL on your own, okay? You gotta use the table, right?
Professor, I have a
Yeah.
question about CL table.
Huh?
So our group try to do this CL table, but we couldn't figure it out how to get the minimum and the maximum values from the CL table.
Okay, it's the boundary, right? We did some examples, remember? We did some examples a few weeks ago. Let me do that again for you. That one, raw data for, where's the CL? Video. No, it's not video I want. I want lab. Is that here? No, it's not here. Confidence level table. Where's that? Oh, here you go. Confidence level. Here's the table.
Yeah,
Okay, so
we use the table, but
here you go. Here you go. You should look at this row because it's 6, right? N equal to 6.
mhm.
So here you go. This row right here. What's the value of my R squared? Let's take a look of my R squared. 99690. Look for 99690 in this row. Okay, see, 99690 is between those two values. Okay.
Oh, okay. So it must be okay.
Lower bound is this one. Upper bound is this one. Right?
Right.
So for my case, your case might be different.
Yeah, it should be different, right?
Yeah, for my case, what you're going to do? For my specific case, the CL lower bound is going to be, you got to put the equal sign. 1 minus 10 to the minus, is that the minus 6? Or minus 5? Minus 5, right? Yeah, it's minus 5. It's those two, right? Right? Those two here. 6. Yeah. It's 996. 996. Yeah, okay, so that's right. 10 to minus 5, 10 to minus 6. Okay, minus 5 here. Don't forget to put equal sign. You want to change the format. You don't want to leave like an exponential, right? And the other one, oops, go back here. Yeah, minus 5, minus 6. 1 minus 10 to the minus 6. Okay, let's change the format here. I'm going to put as many decimal places as I can. Put in numeric format. Let's see how many I'm gonna put. I'm gonna put 6, 7. Let's put 7. Okay.
Okay. So if it converts to numeric, I mean the numbers it's okay, right? We don't have to like.
Well, if you're lucky enough to have a number that is exactly, most likely that's not gonna happen with you. Okay, but if it happens, let me know.
Mm-hmm.
I have seen only one instance throughout since 2003 that I have been teaching. I have seen only one instance. If the actual data, the R square in the data points there coincide with any of those numbers. Right? It's just so 2003. I've been teaching for 20 years, right? So in 20 years, I saw only once in my whole out of thousands of lab reports that I saw. Okay.
Okay. And I have one more question.
Yeah.
So my quantity, I mean my slope percentage difference box appears to be like this value, like I cannot like find the actual slope percent differences between the actual values and stuff.
Are you talking about the percentage difference here?
Yeah.
Okay. Do you see numbers like that?
I don't see numbers like that. So mine's are like values.
Okay. Okay, I know why. Most likely you didn't type the density right here at the top. Check that at the top.
I did. Oh, maybe I typed the units. That's why. Oh, yeah. Okay, without the units, I think.
Don't put the units. Yeah, it has to be a numerical value. The unit is already here at the top.
Okay.
If you put the units there, the equation that I typed here is not going to recognize the unit, right, as a number.
All right. That's
Okay, that's
it.
why you're getting value there. Yeah.
Thank you so much, Professor.
Any more questions? Let's see. I want to make this font look nicer. Nope, 16 font 16. Okay, here you go. Good. And 12 o'clock, we're done, right? 12:01. You don't have any questions? Okay, we are gonna meet again for this lab next time. Let's see what I'm gonna do. No, you don't have to worry about the lab report yet, okay? Let's meet again about this lab next time. And then I tell you what to do. Here's the, see, let's see. Let's see, we're still going to do lab 1 next time. Okay? So after that, we can, I'll give you more instructions on how to submit this lab report. Okay, so see, any questions? No questions here. Okay, so I see you Monday.
Thank you. Professor, I have one more question.
Yeah.
So it's about the CL value. How do you how did you get the actual values like
Well,
that?
just like I did, right? You know, I type it equal 1 minus 10 to minus 6 to minus 5. And then Excel does the math for me. 1 minus 10 to minus 6, right?
Wait, hold on. Can you show can you show me again?
Just type it here. Equal 1 minus, you have always to put the equal there. Otherwise the 10 to minus 5. Okay?
Okay.
And that's the calculation for you. It's a very common mistake that the students type the number without the equal sign. It's a very common mistake. If you do that, Excel is going to treat this number as though it's a text. That's why you must put the equal sign here.
Okay.
Must put the equal sign there.
Yeah. Let me try again.
Okay. Let's see, 1202. Okay, so the format, the read one, yeah, you want to format as a number, okay? Not as a scientific format.
Number? Okay.
And number is, let's say, I put 7 decimal places here. Yeah, I put 7 decimal places, the CL.
Okay.
Okay.
Let me see.
And also make it large enough so it's easy for us to read, right? This one here, I'm using which format size? Font size, I'm using 16. Font size 16. I want you to finish this table, right? Finish this table is the graphs, and then we discuss what we did next time. So you know what you're doing.
Okay.
Any more questions?
Professor, I'm trying to plot another graph, and when I try to highlight another series of columns, it won't select what I'm trying to get it to.
Yeah, there's a little trick there, right, Eric? Highlight mass, right? You did that, right?
Yes.
Right? And then what are you going to do? You're going to highlight this column here, right? If you don't do anything, what happens? You miss this highlight, right? Is that what's happening to you? You highlight this one, and this one disappear, right? You notice that?
Yeah.
Is that what you're having? So there's a little trick. You highlight this one here, and if you have a PC, you have to press the control key. When you press the control key and highlight this column, both of them are highlighted simultaneously. The highlight of both stay, huh? There. Make sense? Hello?
Yeah,
highlight, press Control, highlight.
I do have a Mac, so would that be? I have.
Must be the command key. Mac must be the command key. Try the command key.
I'm not too sure if I got the right value and stuff.
Yeah, we're going to revisit that again next time. Don't worry. Work as much as
Okay,
you
it worked.
did you get it? Did you find it? Did you manage to do that, Eric?
Yeah, so when I highlight it, I'm gonna hit insert and then scatter plot.
Yeah, insert scatter plot, yeah.
And then show equation, show.
Do you get data points like that?
Let's see. Yes.
Okay.
Okay. Yeah, that's all I need to know. So I just need to work on getting the 3 charts done for every tool using the mass on the right corner
No.
or the measurements on the